Hey, this is ChronoAB, and in the previous video we made this script, which is a procedural generation script. And in this video we'll be improving the script by using tilemap instead of these game objects to spawn our tiles like we did here, which will give us more performance, as well as we'll use Perlin noise to generate our terrain instead of using it like this, which will give us a more naturally and good looking procedural generation. So with that said, this code is in the link in the description. Please download it, and you can also watch the previous video in the card above to understand about how this code was made. And now with that said, let's get started. Now let's open this script up. And as you can see here, this is the script that does the procedural generation. Please do watch the previous video to understand it more properly on how we have made this. But in short, what's going on here is that basically with these 3 lines of code, we give a random height value. According to that height value, as you can see here, we find the total stone spawn distance. And according to that value, we either spawn a stone tile or a dirt tile. And at the top, according to our height, again, we spawn our stone tile or the grass tile. And that is all that is happening. Please do watch the previous video to know it properly what's going on here. And what this function does is basically it'll help us spawn the items, any tile, and then make it a child of our procedural generation game object. Meaning when I hit play, what's going to happen is, because of all that calculation, this happens, and at the end, all of them will be a child of our procedural generation game object. So with that said, now let's add some tile. To make our tile maps, what we need to do is first of all make or write a namespace at the top called using Unity engine.tilemap. So let's make a duplicate of this and write using Unity engine.tilemap. Now here, let's make a placeholder for our dirt, grass and stone tile called tilemap basically. This is where we will spawn our tiles. So write serialized field tilemap, and let's have a individual tilemap for individual tiles. So for the dirt, write dirt tilemap, and let's do the same for grass and stone as well. Now let's save this, and back in Unity, we'll have 3 places to put our tile maps. So let's create a tile map in the hierarchy by just right clicking here and click on 2D and tile map. So there'll be a grid, and inside here you can see a tile map. Let's just rename this one to ground. No, not ground, actually dirt. Right, let's rename this to dirt, and let's make a duplicate of this, rename this to grass. And then rename another one to stone. These are the 3 places where we will spawn our tiles. So let's just drag and drop it onto our component here. So dirt tile map in the dirt tile map, grass tile map here, and stone tile map here. Now let's make a reference to our tile, which we will do by writing serialized field tile. And for dirt, write dirt. For grass, write grass. And for stone, write stone. Now because there's a conflict, because 2 things have the same name, so let's just comment this out. And once we comment this out, because there is no game object anymore to spawn, so they'll say a problem here, so comment all of these out. Now, once we save it, let's go back and you'll see 3 places to put our tile. Let's make our own tile by just right clicking here and create, and in tile, just click on tile. It'll ask you to write the name of the tile asset. Let's just first call the first one dirt. It's a dirt tile. Here we can put in our sprite. So in the sprite section, just put this tile. This sprite that we made, and let's just change its color. All right, you can actually put any tile you want, any kind of tile, make your own tile. For now I'm just putting some random color here. So for our dirt, let's make it a dirt color. Alright, so this is our dirt tile. You can also, I think, make a new tile palette. Just create that. This is a tile palette and just drag and drop it here. And now what we're going to do is we are in the computer. We'll tell the computer to just do this. Spawn a dirt tile inside our dirt. So now after making dirt tile, let's just duplicate this and make a grass tile. So in the name right here, let's just change it to, and do the same thing again and make a stone tile. So in the grass, let's change the color here to a grass color. Okay, and I changed this to a stone looking color. So let's just drag and drop it here now. So dirt on dirt, grass on grass, and stone on stone. Now here what we will do is, now instead of these line of code, what we are going to write is, now here we need to spawn a stone on the x, y coordinate. So what we are going to write is, because we are going to spawn a stone here, write stone tile map dot set tile, and inside we need a vector3 integer. Now why we need a vector3 integer is because, okay, let me show you here. Just click here, and if I click here, as you can see, the position on the y-axis, as you can see, on the x-axis actually, as you can see, there is only a whole number. You don't have some kind of like 6.5, right? It only takes in a whole number, and an integer is only a whole number. So that's why we are going to use integer. That's why this line of code uses integer. So vector3, for that just write new vector3 integer, and inside you just need to write x, y, just like here. But it also has a vector3. Because it's a vector3, we need one more thing. This is a z-axis. For the z-axis, just write 0. And now we gave the position, but we have not given what kind of a tile we want. And for this, because we are going to spawn a stone tile, write stone. So now let's do the same thing here and here as well, just changing the tile name and the position accordingly, as well as the tile map accordingly. Let's just copy this, paste here. Let's change this to dirt tile map, and here to dirt. Let's do the same here as well. So there will be a stone, so it's not a problem, but on the y-axis we need height instead of writing y. Alright, copy this, paste it here, and height is great, but we are going to spawn a grass, so let's have a grass tile map, and a tile will be grass. Now once that is done, we don't need this function anymore because we're not going to spawn a game object, we're spawning tiles. So let's just remove this. Alright, and now everything is done. Basically now we can spawn tiles. Now if you just click play, what's going to happen is, as you can see, we have spawned tile. And if I can show you each and every tile, the dirt should be in its own position. As you can see, the dirt has its own place. Yep, that is in its own place as well, and this is on its own place as well. Now the reason why we did this is it gives more performance. I mean, we can spawn a lot more objects without having any problem with performance, and let me show you that. So first of all, this is bugging me so much, I have no idea how to remove it. Alright, shift and okay, my OCD is cleared up. Now let's say, because we only had like 80 different objects, right, 80 on the width and 30 on the height, that's why there was no problem spawning it. As you can see here, nothing feels any slow, right? What if, let's say I want about 100 on the height and let's say 300 on the width, maybe even 3000, but let's start with 300 on the width. That is a lot of objects. If you think about it, 300 into 100, meaning there'll be 30,000 different blocks here. So once we hit play, what's going to happen is basically nothing. See, it is still performance. Each and every one of these is a tile, but for us to actually click, you have to click it like this. See, every tile, but it is way more performant. So that's why we're using tilemap. Now let's put Perlin noise to get better procedural generation instead of these 3 lines of code. These 3 lines of code help us spawn the stone, so we don't have to do anything. This we have to change. So, but before showing you how we can use a function called mathaf.perlinNoise, which gives us a Perlin noise, kind of a feature, kind of a randomness, I'm going to show you something else, which is an example I made. Let's just first of all close this. All right. So this is an example I made. This is an example script where according to the height, your Y position or this item's Y position will change. And we are going to use Perlin noise to change that position about randomly. So here, let's just write height is equal to mathaf dot, nope, not math dot, mathaf dot Perlin noise. So here it takes an X and Y value. We can just write one value either on the X-axis or the Y-axis because only we're taking one value, right? So we don't need to worry about that. Now let me tell you something. What happens if I just put a, let's say 2, 0. Let's see. What will happen is basically, let's just go here, hit play. What's going to happen is it changed its Y-axis as you can see, but only once. Nothing happened. It did not move at all. We want it to randomly move up and down, right? But nothing happened. The reason why is because first of all, we need some kind of a changing value, right? Let's say instead of putting 2, like a constant value, let's put some kind of a changing value which changes every second, like time dot time. Let's hit save, and if we go back here, hit play, what's going to happen is now as you can see it is moving up and down. Even here, as you can see, it is moving up and down. Now it is fine and all, right? But it's fairly low. What if I want this object to move up and down, but up here? How can I do that? Is basically by multiplying this Perlin noise value with some amount of height value. So let's make another float, which we will show in the inspector. So serialize field and height, HEITST, VALUE value. So if I multiply this with our height value, not height actually, just height value, then now according to this height value we'll have a higher level of value. Let me just show you that. All right, let's say height value will be 30. So let's hit play. And as you can see here, it was here, but now it's here. And as you can see, that's a lot of fluctuation as well. If I put a height value as, let's say 70 maybe, 70, and as you can see, it is way up there and it is way more fluctuating as well. Now, let's say the height is okay, but I want to also have less fluctuation, right? I just want this height, but low fluctuation. So what we need to do is basically we need to smooth out or just divide it by a smoothing value. So let's just put a comma, height value and smoothness. Once we do that and just divide it by smoothness, then now if I write like 60 here, then what's going to happen is the height will be same as you can see, but now it is kind of smooth out. It's not moving that radically. And this gives us a smooth looking procedural generation. If you put this line of code inside here, then it will give us a smooth looking procedural generation. So basically we're just gonna copy this code and put it here because it will work perfectly. So let's just do that. Let's just copy this, Control C, and instead of this guy here, let's just put it here, Control V. Now first of all, we need to remove this because we don't need to show it in the inspector. So let's remove this and write int height is equal to height value and smoothness, right? And here for the height value and smoothness, let's just make a float height value HEIGSTVALUE, comma smoothness, height value and smoothness. Now it is saying that something is wrong because this is giving a value in float, but the end result should be in an integer, and frankly C# cannot convert it to an integer, so we have to do it on our own. So let's just put it in a small bracket, and out here just write mathf dot round to integer. So this will round everything up to an integer and everything is fine. Now this time.time, we don't want to do it forever, right? Time.time keeps on going forever. We want to stop at a certain point. So instead of putting a value that changes forever, let's put a value that changes for a certain amount of time until x is less than width, right? So let's put that here. So just write x and we are done. We are done. Now here, let's just have a slider. Instead of being able to put as many values as we want, let's put a slider, so which will have a range starting from 0 and ending at 100. So for our height and smoothness. Now according to this, what's going to happen is according to this height and smoothness, we will have a random generation. So we have more flexibility and control on how our random generation will be. If height will be bigger than the smoothness, then it will be more fluctuating value. You will see what's going to happen. And if smoothness is more than height, then it will be more like a smooth kind of generation. You'll know what's going to happen. So once we save this, let's just go back into Unity. Let's just close this because we don't want to see that, and let's reopen this, and as you can see we have a height value as well as a smoothness value. So here let's not put 300, let's put something like 80, and in height value let's say we have a height value of 50 and a smoothness of only like 20. Now what's going to happen is when I hit play, as you can see, because the height value is more than the smoothness value, it gives us big fluctuations like this, right? Let's make it easy for us to do that, right? We don't want to keep on playing and pausing and playing and pausing all the time. So here let's make a update function. So void update, and if input dot get key down key code key code dot a. So when I press the A key, it will do our generation. And if I press the D key, what's gonna happen is it will clear up everything. So to clear up everything, we have to do is write like stone tile map dot clear all tiles, and we have to do this for all of them. So let's just make a duplicate here. Oh, I have to write small bracket here. Let's make a duplicate of all of this, 1, 2, and replace the name. So if I press the D key, everything will get cleared, and if I press the A key, everything gets spawned. So now we can do some testing here. So as I said before, when we start, what's going to happen is, because this is greater than this, height is greater than smoothness, I just create some kind of a heighty platform, right? So let's just clear it up, everything, and let's say this time smoothness will be more than height. What's going to happen is, as you can see, it is way more smoother. If I put really low height, then the overall height will also be lower, right? Let's just, oh shit, yeah, I made a mistake. Wait, let me just clear everything, and A, as you can see, it is really low. If I do the same thing again, and if I put this and this like here, then let me just clear it up, and A, and as you can see, that is a lot of, so you get the point. Now let me just make it a single value like 50, and let's put both of them at 50, right? So last time, let me just show you. Now every time I clear it, let's say when I press the D key and A key, as you can see, nothing changes. The procedural generation is totally the same. Now let's fix that. So finally we'll just fix that and everything will be done. So to fix that, we just need to put a kind of a float called, we need a float which is a private float called seed. Now what is going to happen is basically according to this seed value, we'll spawn different kind of platform. So how we can do that is just by, instead of writing this, write seed here on the y-axis, and because of this value, if I, for example, let me say right now we had it on 0, right? That's why, oh, let me show you that. Yes. Okay, let's make it serializable, all right? Let's make it serializable and let's put seed here, and right now seed is 0, right? As you can see, seed value is 0, and if I hit play, the same terrain is generated. Let me just clear it up and let's put 1 here, and when we hit play, as you can see, this is a different terrain. Let's put another, let's say 1000. Let's see what will happen, right? Let's just clear it up and hit play. This is a different terrain. So with this seed value, we can have different terrain. So now here, every time before we generate anything, right, we need to write seed is equal to random dot range, and that range, let's say, will start from negative 1s, 10s, 100,000, 10,000, 100,000, million. Okay, it will be negative 1 million to a positive 1s, 10s, 100,000, 100,000, million. So it will start from a negative million and end at a million, and we'll just find a random value from here which will give us a random generation, and let's do that here as well. All right, in my case I did it like this, but you don't have to do it, right? The generation will only happen once, so we only need to put it here, but for demonstration purposes I just made this. You get the point. So now actually everything is done. We have procedural generation. Okay, yeah, this will be fine. We can see which seed we have generated as well. Now, as you can see, some 1s, 10s, 100,000, 10,000, 100,000, some 800,000, and we get this. Let me just clear it up. Another. Now you get the point. So that is it. Thank you for watching. If you like the video, smash the like button, hit the subscribe for more content like this, and press the bell icon to never miss the latest video. You can download this script from the link in the description, which is an asset bundle that I'm working on, which has this script, the last 2 procedural generation script we made, a loot spawning script that we made in a video, an older video of mine, many other things as well. I'm trying to make a bundle that will help you prototype a game as quickly as possible, so please do download that. More updates are coming soon, and with that said, again, thank you for watching and bye bye.